Alright, so we're looking at lesson 21 today. We're looking at momentum. So hopefully after this lesson you'll understand how momentum works. The product of the mass of an object and its velocity is called the momentum. So that's where momentum comes from. So if you have a larger mass and you're going at the same speed as someone else that has a much smaller mass, then the larger person is going to have a bigger momentum. If you think about an 18-wheeler and a little bitty sports car, if they're both going 70 miles per hour, the 18-wheeler is going to be a lot harder to stop because it has more momentum. Momentum is a Latin word, and the plural of it is momenta. So if we're looking at the plural of momentum, it's momenta. And that's because it's a Latin word. The um is singular ending, and the a is a plural ending. This is your formula. Momentum is just mass times velocity. So if y'all want to write that down, y'all can. Since your acceleration is just a change in velocity per time, F equals ma can actually become F equals m, and then change in velocity over change in time. And if your mass is constant, then we can write it like this: change in mass times velocity over change in time. And then you can multiply both sides by your delta t from here. Just multiply the delta t over here, and you get this equation. This is called your impulse, and this is called your change in momentum. So that's a formula you probably want to write down on your formula sheet. Your impulse and your change in momentum. If you have a man that pushes a block with a small force for a long time, he gets the same change in momentum if he pushed it with a big force for a shorter time. So since force and velocity are vector quantities, you can say F sub x delta t equals change in mass times the velocity in the x direction. Since your mass doesn't change, you can actually say the change in velocity is whatever your v2 is minus your v1 and distribute the m. So you could write this equation here. And this would be your impulse momentum equation down at the bottom. So you may want to write that equation as well. This one here. Okay? So we're going to look at an example. Depending on the problem that they give you, depends on what and the information they give you, will change what formula you're going to use. So they give us the constant force of 40 applied to a 10 kilogram mass for 10 seconds. What was the impulse? Well, impulse is just F delta t. So for the impulse, you're just going to do force, which is 40, times your time, which was 10, and so your impulse is 400. And we have two sig figs, so it's going to be 400 with a bar, and then force is newtons, and then time is seconds. So Newton second, not Newton per second, Newton second. So that's your impulse. B, what was the change in the momentum of the mass? So your change in momentum is going to be the same thing as your impulse. And so our impulse was 400, so our change in momentum is also going to be 400. So you don't really have to do any work there. And then what was the change in the velocity? So we're going to use this whole formula here. I'm going to write it like that, where the mass is factored out. And you could also write this as just delta V, because it wants to know what is the change in velocity. So if you'd rather use this equation, you can. And so we know that the F times delta T was 400 from earlier, and we know that the mass was 10, and we don't know the change in velocity. So if you divide by 10, you'll get that the change in velocity was 40. And again, we have two sig figs, and units on velocity is meters per second. So that would be your answer for that one. Okay, we're going to look at another example. It says, how long should a constant unbalanced force of 40 newtons be applied to change the velocity of an 8 kilogram mass from 40 meters per second to 85 meters per second? So we're going to start with our formula. So the force is 40. And it says how long. So what is the time? We're not sure about. The mass is 8 kilograms. And then we have from 40 to 85. So we're going to do 85 minus 40. So you have 40 delta T equals 8 times 35? No, 45. And then you're just going to solve for your delta T. And I get my change in time was 9. And I only have one sig fig from all of my numbers up there, so the change in time is just 9 seconds. And so that's how you can use your formulas. So again, you want to put those on your formula sheet so that you don't have to memorize them, because there are a lot of different ones, and it just depends on what they give you as to which formula you're going to want to use. So your homework is 1 through 20, and the curveball questions 1 through 5. So make sure y'all do that tonight so you can go over any questions you have tomorrow.